Hello, this is Coach Stoney. Hope you're having a wonderful spring break. Hope you're looking over this. Don't forget to get out your notes to go over this here first. Take some good notes. This is our first lesson on when we flip the classroom. And here we go. It's about rational functions and their asymptotes. All right, this is chapter 2, section 6. And let's find out a little bit about it. First off, let's have an introduction to rational functions. What is a rational function? Basically, a rational function can be written in the form. Basically, you have a numerator and a denominator. The denominator has an x in it. That's all a rational function is. A rational function is a function that has an x in the denominator. Because that's going to cause some problems and things. It's not like it's going to make straight and continuous problems here. So let's kind of look at it. Oh, legal disclaimer. Got to have a lawyer. Remember, the denominator cannot equal what? Ever. 0. What happens when the denominator equals 0? Well, it doesn't work. So, let's go. Finding the domain of a rational number. So first off, let's just kind of think about this for a second. Let's take the parent function. The parent function is 1 over x. This is the most simplest rational function that we can work with. And so let's just kind of take some numbers and plug them in. So first off, if you were to plug 1 in for x, well, first off, you get 1. If you put 0.5 in, that's the same as getting 2. If you put 0.1 in, that would give you 10. As you can see, 1 over 0.1. If you put 0.01 in, what do you think you're going to get there? 100. If you put 0.001 in, you're going to get 1,000. So what would you think would happen if you have 1 over infinity as a number that you put in? Well, think about that. And how do you do that? You would multiply the reciprocal. So that's the same as getting infinity. So, as the number gets bigger and bigger, or smaller, it's really getting smaller, smaller, and smaller, our number here is going to get larger, larger, and larger. It's going to go to infinity and beyond, but it's never going to quite. So we're going to get numbers going to be going up big. What would happen if all those same numbers were negative? They'd be the exact same values, except they'd all be what? Negative, right? So guess what that's going to do? As we get closer and closer to 0, we don't ever quite get to 0. The numbers are going to get really, 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 really large. Well, what's that going to do to a graph? Oh, look at that. It's going to form what we call an asymptote right there. That nice red line right there. It will get closer and closer, but it will never actually touch. So let's think of MC Hammer. Can't touch this. Can't touch this. All right? Sorry, that's my best MC Hammer that I got for you. So basically, you will have on that graph of 1 over x, x cannot be 0 because at 0 you cannot divide by x. So in that forms, we call this red line here the asymptote because you will never touch this. Can't touch this. And that's one picture of MC Hammer right there. Hope you know, can't touch this. Can't touch this. All right? So, go ahead and stop it.